This meeting is being recorded.
Good afternoon, good evening, everyone. We'll just wait for a minute for everybody to come in, and then we'll start the session. As everybody is joining, I'll request everybody to give their introduction in the chat box so that this session will be a bit interactive. We could actually know people by name and the association. And Basanta, could you please keep yourself on mute? I'll go ahead and start the session. Hello, everybody. Good afternoon, good evening. Institute for Sustainable Communities welcomes you to this informative session on the potential driver for net zero manufacturing, and that is community steam generation. We are happy to host this webinar in partnership with TIFAC, that is Technology Information Forecasting Assessment Council under the Government of India, and SteamHouse India Private Limited. Before we get into the session, I will quickly want to run some housekeeping rules. We request everybody to be in listen only mode, especially when somebody is talking. We would be requesting you, this is optional, to add your introductions in the chat box and your queries in the Q&A box that's there. We will be assigning the questions actually to Vishal whenever they come up. We have kept 2 dedicated Q&A sessions within the presentation, but we could kind of make this interactive if we have something very immediate coming out while he's presenting. Before we get into the session, I would like to request for permission. I've actually already started recording this session, and the whole idea is that we would make this session available on YouTube. And this webinar will be basically followed by a site visit so that we can actually go see the installation and understand what are the feasibilities and applications, and just have a hand-on experience ourselves. We would plan this after this webinar. I would get in touch with you. I'll get a sense of who all are interested. We'll circulate a doodle for that, and that's about it. So we'll dedicate these good 1.5 hours to understanding how we can actually progress towards a net zero manufacturing sector. The whole session basically would be planned out in such a way that we'll introduce Dr. Basak from TIFAC to give the need, benefit, feasibility, because they have worked with over 45 clusters in India, and can give the ground reality of what's possible, how is it possible, a way forward towards a net zero commitment that India has taken up. Followed by Vishal's presentation on the implications of community boilers on resource conservation. So the first part of the conversation will basically be to explain the concept, the technicalities. Then we'll break into Q&A. And then the second part of the session, which would again be led by Vishal itself, will go into case study and whatever they've implemented and the new innovations that they have done with each pilot that they have gone ahead with, again followed by a Q&A. And then we'll sum it up with me and Nasha, I will try to give the India perspective of how we can think of a way forward, who would be interested, and Nasha will talk about what get a point of view from the private players that are actually based in South Asia, to talk about how we can pave out a future and how we could actually make this a viable proposition for not only India but all the countries that are still relying on coal fired, especially baby boilers, in this ecosystem, to reduce our reliance on coal. I would now request Dr. Basak to come in and give us a perspective of what does the Indian government really foresee, and how we can think of making community boilers a proposition into the ecosystem of the manufacturing sector, to make it a scalable project for India as well as South Asia, if possible.
Thank you, Megha. Very good afternoon to everybody. Am I clearly audible?
Yes, sir.
Okay. Myself is PR Basak. I'm scientist in Technology Information Forecasting and Assessment Council, TIFAC, which is an autonomous body of the Department of Science and Technology, Government of India. We are looking ahead to the emerging technologies which are of national interests in terms of environmental friendliness, in terms of green technologies, in terms of business propositions for the industries. So TIFAC has been into the technology assessment and innovation vertical for a long period of time, and we have been also implementing several projects technology based towards implementation in networking with academic institutions, R&D labs, as well as industries, particularly the MSMEs and startups. Presently, I am heading a program which is technology, TIFAC SIDBI Technology Innovation Program, SRIGEN program, which facilitates innovative technologies scaling up through participation of MSMEs and startups, where TIFAC is doing the technological assessment, techno-economic feasibility studies, their scalabilities, and SIDBI is doing the financial assessment, and they are providing the support through a revolving fund. So TIFAC actually is having very good backbone and expertise in this area. Now coming back to this MSME sector, which is called the actually growth engine of the country, because 45% of our manufacturing coming out from the MSME sector only, and which actually accounts for about 8% of our national GDP. So as India has already set ambitious target of reaching net zero carbon emission by the year 2070, an interim target of around reduction of 45% carbon intensity by the year 2030. So definitely we have to embark on a path towards sustainable manufacturing through utilization of clean and green technologies. It is imperative to have several policy interventions to create potential for clean tech market, and also to accelerate green financing opportunities in this particular sector. So clean technologies should be competitive, if not superior, to the conventional counter technologies in the true sense. So whatever technology we are talking of should be very much competitive with the conventional one. Otherwise, industry will not get excited to adopt those technologies. So clean technology can be defined as any process or any service that would improve the productivity, the energy efficiency, and of course less GHG emissions, and as well as cost reduction, which is very important for sustainability of the industries. So cost reduction should be there at the same time with the less GHG emissions. As we already know that this Institute of Sustainable Communities has partnered with TIFAC towards promotion of accelerating clean and equitable manufacturing in the MSME clusters in selected domains. In this endeavor, this Institute for Sustainable Communities and TIFAC are partnering with various technology developer and technology know-how provider and various agencies also, to come out with some technological solutions to the problem statements being faced by the MSMEs and startups to achieve their productivity, to achieve some hassle-free operations, which is very important, and better economics through promotion of this renewable energy or any energy efficiency technologies like automation in manufacturing sector or service sector as well. So today's webinar, which is being conducted by SteamHouse for providing community-based boilers, which is very important because we have once listened to the presentation of Mr. Vishal Budia, because almost all industries, particularly in the textile cluster, like the dyeing industries, they require steam and hot water as well, and boiler is required as a service for everybody, utilities. So if instead of using individual boilers and facing some hassles of licensing, maintaining those boilers, maintaining the manpower, initial capital cost, let us go by for a community centralized boiler which can cater to some 8, 10, 15 individual units instead of having standalone boilers. I think it would be better in terms of economics as well as hassle-free operations by the industries. So I am just looking forward to the presentations today that Vishal is going to make, and I would invite all participants to come out with their questions after listening to the presentations, and please clarify your all queries today itself and show your interest, so that Megha would subsequently arrange for a site visit for a live demo in some case studies that he will present, Vishal will present, so you could have a better feel and having better confidence after looking at those demonstrations. So before that, let us clarify all technicalities, know-hows, advantages, impacts, and cost economics, everything in today's discussions. So I hope such a technology solution would certainly be a scalable solution, and that would facilitate manufacturing to the manufacturing industries to comply with the stringent environmental norms which are going to come very shortly. And of course, that will give value addition to your products for very good market opportunities in India as well as for the export market. And that would ultimately aim to achieve our green and clean Atmanirbhar Bharat. So thank you all. Over to you, Megha.
Thank you, Dr. Basak, for setting the tone for the session. And the interesting thing that I learned about Mr. Vishal Budhia was that, he was a textile owner, and because he wanted to have a vision towards, trying to achieve net zero commitments and reduce emission, he himself figured out through Jugaad innovation, I would say, this whole concept of community boilers. And this is a single person run mission where he has managed to do 3 pilots, and now going to 3 more states, and also trying to achieve this further in South Asia. So I'll give it over to you, not waste any more time. And I'll stop sharing my screen and give you access to share the screen. Over to you, Vishal.
Yeah, good afternoon, Megha. Good afternoon, Meghna. Dr. Basak, thank you so much for setting up the tone, and Meghna for the kind words and the introduction. I'll start my screen sharing now. So I believe my screen is visible now and presentation is there.
Yes.
So yes. Steam boiler, as we all understand, is considered to be the heart of the industries. And we see the use of steam not only in textiles, but in paper mills, food productions, pharmaceuticals, pesticides, chemical industries, and many other processes. And it is also used for multi-effect evaporators, which is the requirement for managing the effluents these days. So multi-effect evaporator is also needing a lot of steam. Boilers in range of say 250 kgs or even smaller are in operation, and ranging up to say 100 tons per hour. And we believe that there are 30,000 plus boilers currently installed in the country. in India alone, where these boilers are installed for the purpose of heat alone. I'm not talking about the captive power as of now. So community boiler, or common boiler as we call it, is a unique concept where the idea is to have better efficiency, better safety, and the most important portion is the reduced air pollution. So selection of the right technology like AFBC boilers or CFBC boilers, which are higher in efficiency as compared to water wall boilers or package boilers, and selecting the right air pollution control equipment, because though the technology available is very old, it's around 150-year-old technology and very proven. ESP, the electrostatic precipitators, is the best thing for the reduction of solid particulate matters in particular. But the challenge is that it needs a large footprint and larger capex. That's why it goes well only with the bigger boilers. We already have around 90 industries, 90 boilers replaced by 3 projects in Surat, Vapi, and Ankleshwar currently. I'd like to just mention a few differences, major differences between individual boilers and community boilers. The boilers are in range of 250 kgs and 210 dph, most of the industries that we would like to cover or cater to. While the common boilers we target is currently in 2 modules, 30 dph and 60 dph, with lots of permutations and combinations. We feel that these 2 are the best numbers to be adhered to. In person, SteamHouse also finds it good because the inventory also reduces the maintenance parts, the replication of whatever machinery and design we are using, and we have to focus on improvement on particular numbers, not on the whole set of engineering. In smaller boilers, we generally know that the design efficiency is 65%, while since they are not professionally operated or not always made by very good manufacturers, the efficiency can go as low as 50% or even lower. While the design efficiency in AFBC boilers is 83%, in CFBC it is 85%. So by design itself and by operations, of course, the efficiency is higher, and we can say that around 28% of the same fuel, if we are talking about the fossil fuel or if we are talking about the biomass, whatever the fuel is, at least 28% reduction can be assumed by the design itself. There is a higher ash generation in smaller boilers, which is causing the fugitive emission as well. And that is also because of insufficient or inefficient burning of the fuel, and also the selection of the fuel, because smaller boilers are generally buying the fuel in retail, while a bigger boiler will always buy on a larger scale and can go for a better QC and can actually adhere to their own requirement and stick to what they want to buy. Chimneys in industrial, in small boilers, we have already seen is mostly mild steel, MS make, and they need higher temperature for the life of the chimneys. While in case of RCC chimneys, you can take the temperature to as low as 100 degrees, 110 degrees. So this also reduces the global warming and increases the efficiency. Design benefits, as we have already discussed, it's you can use the right air pollution control equipment, which in case of smaller boilers is always challenging. Even the bag houses, which are said to be the best, even better than ESP, if we say for result sake. But we know that bag houses have not been so successful in smaller industries due to moisture content or higher temperatures. And we have seen accidents, rather fires in case of bag houses in several places. SOx generation is higher because people don't really stick to low sulfur fuel, while in case of bigger boilers, we can decide on not going for fuel above 0.6% say sulfur content, and also using proper technologies to infuse hydrated lime on the fuel, on the coal itself, coal or any other fuel which we select. NOx generation, we talk about gas and furnace FO-fired boilers, that they are better in, they do less air pollution, but we all know that the bed temperatures in these boilers is 900 degrees plus, and NOx generation starts at these temperatures. While in AFBC boilers design is for 800 to 850 degrees, and therefore NOx generation is lower. And I don't need to remind you here that NOx and SOx are the main reasons of acid rains, and they're 200 times more potent than carbon dioxide. So AFBC, I actually don't need to introduce AFBC boilers to the people here because most of you are from technical background. But AFBC by design are the best technology available. Capex versus efficiency. While CFBC boiler is also existing now, and many new boilers are CFBC boilers, but the challenge is capex wise they're almost 3 times than the AFBC boilers. Not only capex, even footprint wise they are thrice AFBC boilers, but both the boilers are good to go with. One more thing, like if you talk about India, the air pollution, the permissions given to individual boilers is in the range of 150 SPM to 800 for emission of carbon, or the SPM permission, while the bigger boilers are given a permission of 50 to 30 SPM. So we can say by permission itself, they are allowed to pollute 70% to 75 to 90% higher, or maybe we can say that common boiler will pollute at least 75 to 90% lower. So we are doing two things here. One is reducing the fuel consumption, that is by increasing efficiency and professional management and selecting the right fuel. On the other side, we are reducing air pollution. So this is where we say when the government or the authorities generally try to say that let's shift to PNG, we say that this is a midway solution which will keep the economics and the pollution both in balance. So we have already discussed about NOx, and also one bigger challenge we have seen that the pollution control boards also find it very tough to visit all the industries. And there are instances where people are using illegal fuel, some fuel like plastic, which is straight away generating carcinogenic gases like dioxin and furan. So bigger boilers are easy to monitor for the department. Like it is like common effluent treatment plant versus the effluent treatment plant. Compliance, again, that same thing is happening. Compliance not only about the pollution control board, but also about the Boiler Safety Act. We have seen that the government at times goes helpless, and people are using non-IBR boilers which are not safe to run. And we have seen many incidences of accidents, casualties, while again having bigger boilers with the right technology, right permissions, SCADA and professional monitoring, the accidents will be comparatively much lesser. Also about monitoring, as we already discussed in the last slide, currently we feel that there are 30,000 boilers operational. So if every 20 boiler is replaced by one common boiler, there will be 28,500 less boilers operating, 28,500 less chimneys emitting smoke, and 28,500 less industries to be visited by the State Pollution Control Board or Central Pollution Control Board. So giving them comfort on achieving the compliance. And also the SOx, NOx and SEMS monitors that are available for the monitoring these days can get a better connectivity from a professional company. It can be an association, it can be a private company like SteamHouse. Health and safety, already discussed in the last slide. Mode of operations, a lot of automation is available, and that is also feasible more with the larger boilers, as we all understand. Cogeneration is one big advantage. So when we talk about preserving the fuel and having it using it more efficiently, so cogeneration is, as we all know, said to be the most efficient way of generating energy. So this is a graphic showing the efficiency difference between only power and a combined process, where we call it cogeneration, where the steam is generated at a higher pressure and supplied at a lower pressure, and in between turbines are added and we get electricity by cogeneration. So the efficiency is much higher as compared to separate energy generations. So again, choosing the right fuel. So it is also important that we choose the right fuel, and it can be mostly decided by the geography. It can be decided on the kind of boiler and the process that is required. And calorific value is not in retail what people talk about is the calorific value, but that is not the only thing that has to be considered while selecting the fuel. So for resource conservation, the other factors like moisture content, sulfur content, ash content in the fuel are also very important parts that has to be considered. So as we see, the efficiency difference itself will say 28% of the resources. The selection of the right fuel and having a QC on the fuel saves 10% and cogeneration 5%. So the efficiency, the saving can be around 35%, 30 to 35%. So on a ballpark number, if 30,000 boilers are almost, as per our calculation, consuming 10.5 million tons of coal per annum. Sorry, we have written it wrong, I believe. It's per annum. And if these projects are completed, we can achieve 7.5 million tons of consumption versus 10.5. So there will be 3 million tons, 35% of saving. And that will also save a lot of forex outflow for any country. The projects in pipeline, the projects which are already commissioned are 4 boilers commissioned and 2 will be commissioned this month. So Sachin, which is near Surat, Vapi, Ankleshwar, Sachin again, and Ankleshwar phase 2, Sarigam to be commissioned shortly, Nandesari and the Dahej are to be commissioned in next 3-4 months. So I'll like to have questions after this.
So there are 2 questions from Mr. Rakesh Kumar. He wants to understand if the fuel is limited only to coal, and because we have to move from coal as a fuel. And then the same part of the question is there any biomass fired boiler?
So exactly, sir, this is the thing which we are working on now and everyone should work on. So when we talk about resource saving, there can be 2 things. One is reducing coal and moving more towards biomass. So even the current boilers which we are using, we have started using almost 5 to 10% of biomass, briquettes, bagasse, and other agro waste that is available in the vicinity for generating steam. So one is we can gradually increase the biomass, one. Secondly, there are boilers, even like Thermax has very recently introduced a boiler where we can use around 11 types of fuel. And almost all varieties of agro waste can be used. Municipal RDF can be used. So this is the best way to shift from fossil fuel, 1, to save our forex outflow, 2, and as Basak sir said, to bring more cost-effective measures for the industry as well as the country.
Okay. Mr. Ramesh asks a second question. Will you cover steam distribution, and also how are you managing varying steam demand?
So yeah, we are selling steam primarily. Electricity is our byproduct and we are not too keen on selling it. Steam demand, as you can understand, that when there are 20 or 25 participants buying steam from one boiler, demand keeps changing. There are a few industries that don't operate at night and some have peak loads. So your question is a very important and good question. We operate boilers at a capacity of 60 to 70%. So we always have a buffer of 30%. And the boilers designed and selected are those which have a good turndown ratio. So these boilers can be operated to as low as 20-25% of their capacity. So yeah, it can be done. And only thing that happens here is the electricity generation becomes a challenge in such cases. So we generally select smaller turbines which actually do not totally cover the steam that can be generated here.
Vishal, do you have any photo to show the steam distribution so that it's visually?
I had it in the presentation. I actually missed to talk about it. So this photograph is a Google photograph of Sachin GIDC, where you can see these white lines. These are the pipes through. This is a Google image, and I'll now show you a photograph of the pipeline. Is my screen visible?
Not yet.
Just one sec. Okay, maybe I'll show you that slide in the second presentation where we have a proper photograph of the pipeline network we have.
Okay. One more question from Mr. Raj Kapoor. Can hydrogen or solar be used in boilers?
Yes, we are. We have already tied up with a company based out of US, and with them we are working on a pilot project. We hope that in the next 12 to 15 months we'll run our first pilot project on green hydrogen, or hydrogen as you can call it. And solar, there are challenges because solar generally needs a larger space, and these projects can be done in the existing industrial estates where the density of industry is already higher, and it is tough to find such land, and the prices of the land will always be very high. So solar, I doubt we can do much.
Okay. One question for Amit Kumar Parihar. Can we explore possibilities of using renewables, mainly solar thermal? To start with, can we target to partially replace coal?
So it's almost the same question, but solar thermal, all we can do is some parabolic solar technology can be seeked for, and we can, if not the full steam generation, but at least we can preheat the water which we are feeding into the boiler. So, and as we all know that every 6-degree rise in temperature reduces 1% of the fuel consumption. So it can be a good option, but we still have to work on the economics and the space challenges that might arise. I'm not too sure about the parabolic technologies yet.
Okay, I have a subsequent question regarding pipelines. Basically, how far can these pipelines be built? Because when we talk about some clusters, we don't find all these MSMEs together. So two questions, how many MSMEs can come within one community boiler supply? Give me a maximum and a minimum. And what is the range of the pipeline?
So as we already are operating 3 projects, so in Sachin GIDC, which is close to Surat, we have a 11-kilometer network. And the tail end customer is around 8.5 kilometers from point of generation. We have seen projects in China, and China especially, where the network is 35 kilometers long. So distance is not really a challenge, but gradually the economics might become a challenge because every kilometer of pipeline is around 2 to 3 crore rupees. So if we take it too far, it can be very expensive. So it is a good idea that we have small projects instead of having, one project and spreading it to 20-30 kilometers. Sorry, what was the second question?
How many MSMEs?
Yeah, right. So that depends on the size of the consuming industry. So if the industry, when you are generating say 60 tons and you intend to sell say 45-50 tons, so if the industries are those who are using 500-600 kgs, you can assume 100 industries can be a member. For example, in Sachin GIDC, again we have 30-ton capacity operational and a 50-ton on a hot standby. Here we are supplying steam to around 45 industries. So you can assume, understand that there are industries ranging from 100 kgs to 3 tons, 4 tons. While in Ankleshwar, we have 60-ton capacity, 60, and we are supplying to only 7 industries, out of which 2 industries are half supplied because their consumption is bigger. So the numbers actually depend totally on the size of the consuming industries, one. Number two, if you ask me, when would SteamHouse like to do a project? So if there is an industrial estate where we see a consumption of 15 to 20 tons per hour, we would prefer to start with the 30-ton boiler. So that is the minimum thing I think one should start with. And that should be in a range of 3 to 4 or 5 kilometers at the max.
And what are the safety hazards from pipelines like gas pipes, electric cables? Like, how are you taking care of that?
So gas pipelines are generally underground, and before digging, we generally take permissions and drawing from the local authorities where we know where the gas pipelines are. So that is how we take care of gas. Electricity, as per Indian Electricity Act, we have to maintain a vertical distance of 4.5 meters from the electric cables, overhead electric cables, and 2.5 meters should be the horizontal distance that has to be maintained. So if the cables are not insulated, and that's why our structures are generally 8 meters plus high, and in general we have seen that uh, the electric cables are 6 meters. So when we are crossing electric cables, we take it to 10 and a half or 11 meters high, or even in cases we have taken to 13 meters high, 1-3.
Okay, I'll do a quick rapid fire now. Mrs. Sudhakaran has lots of questions. Pipeline length, maximum length can be what? Anything.
I'll say let's not go above 15-20 kilometers.
Okay, minimum boiler size.
I'll say 30.
Any subsidy that's available?
Gujarat government has announced 2 crore subsidy per project, but that is for an association, not for a private player. One, and we haven't taken any subsidies.
We will buy back both steam and power. What's the cost of steam and power?
Power selling again is a big time challenge in the Indian scenario, and there are lots of restrictions. So selling power is not a good idea. Rather, using power firstly, because power generated in cogeneration is generally low. So we will use it mostly for self-consumption on the boiler. Secondly, if we have some CETP or a bigger facility around, we will prefer to supply to that rather than supplying to individual industries. One more thing to add, we are now also adding air separation plants. So we will be generating nitrogen and selling nitrogen by pipe network. But that is generally used by chemical industry. So if someone from chemical industry is here, he will like the idea. Yeah.
And the cost?
Cost of steam currently we are selling at 4 rupees, but please don't go by the numbers straight, because the temperature of the steam here is 190 degrees. The pressure is 10 bar plus. Steam is dry. Versus the small boilers, which are saturated steam boilers, the temperature is in range of 135 to 145 degrees, and the pressure generally is 7.5 to 8.5. And the steam is saturated, so the moisture content can be anything between 10% to say 35-40%. So the consumption itself will be 35-40% lower in case of our steam.
Okay, I'll take 2 more questions and then I'll take these questions later. So what is the highest steam generation pressure at the generation end?
So our boilers are designed for 45 bar generation, and we then take it through the turbines or through the pressure reduction stations, and dispatch it in the pipeline at 12 bar. So the customer should be receiving it something between 10 and 12 bar.
Okay. So Mr. Pratap has 3 questions. How do you manage the COVID-like situation in terms of fuel price rise? Hope rise of fuel has not been passed on to the end user.
It has to be absolutely passed to the end user. No one can actually take this loss, and especially even government companies will not take the losses now. So yeah, it has been passed. Rather, COVID times the prices have been very low. Post-COVID, the prices went 4 times, as we all know. In last October, the prices were almost 300% plus, and it had to be all passed to the industry. I'm very sorry to say that.
Okay, fossil and non-fossil fuel mixture percentage observed in your boiler?
Currently, we are using 5 to 10% of non-fossil and 90 to 95%. But we intend to, in the next 15 years, we intend to totally stop using fossil fuel. 15 years.
Okay, very interesting question. In Ankleshwar, how do you synchronize multiple users having different processes, usages, or simply how do you recommend the same process? Like,
No, of course, the processes are different and we cannot change their processes. So every industry has a pressure reduction station. And at times people have multiple pressure reduction stations to meet. So the inlet pressure in all the PRS will be same, say 12 bar or 10 bar, whatever is being received by them. And The PRS is so designed so that they can achieve 3.5, 4.5, 7.5, 8.5, or 10 bar, whatever is required by their plant. So they don't have to change the processes. And the consumption, as I said, we have a limit to everyone. For example, if Meghna has agreed for 5 tons per hour of consumption, we'll not let her consume more than 5,500 tons, 5.5 tons per hour.
Okay. And can you throw some light on the safety of the steam pipeline?
Yes. So the structures which we have designed are for 9.5 Richter scale of earthquake, 90 or 100 kilometers per hour of wind speed. We have seen 3 to 4 cyclones in our regions already, and touch wood, we have been very safe. This is about the engineering. The pipes, as we all know, is absolutely under IBR Act, Indian Boiler Regulation Act, which is one of the most stringent act in the world. And each pipe that is used is IBR certified from the stage of manufacturing. For example, in India, there are only 3 companies making these pipes: Tata, MSL, JSL. And the installation is done by certified welders. Post that and pre that, inspection is done by the officers. A hydraulic test is taken by after installation, and a steam test is taken by the inspectors. And yearly inspection is done on the boilers as well by the government officers.
Perfect. Vishal, we'll take more questions in the second round. We would like to understand what are the case studies that you have done, and what are the new interventions that you have brought with each pilot. It would be good to go through that.
Sure, we'll do that. Yeah. So industry in general, we have seen that they are not ready to take a newer decision or do any research on the boilers, because they want to play safe. And even when we introduced our idea to the industries, people were not really ready to accept the concept. So what we suggested was that they should have their boilers on standby. In case of critical operations, please have your boilers on hot standby and start buying steam from us, from a common boiler. So we started with our projects in Sachin, Surat, Vapi. 2017 and 2018, we started our project in Ankleshwar. And these projects now include around 90 industries. That includes range of textile, chemical, pharma industries, and a few food chemical, not food industries as such, but food chemical making industries. Now, these boilers were all on the fossil fuel, and we have seen that people have found it cheaper. People who were not making products which were on steam because they did not have boiler also started buying steam and making products which were which needed steam because steam was now available. Also, people have increased their production. Their quality of production has improved because of better quality of steam. People who are having intermittent consumption, where they need steam only for 6 hours a day, had to actually come, start their boilers, stop their boilers 4 hours before and 4 hours after the their production timing, and they lost most of the man hours. So these have been the advantages to the industry. And in this picture, you can actually see a pipeline network. These are the pillars, Y-shaped pillars with pipe network on it, and the insulation done on the pipeline. The silver color is the insulation that is done on the pipeline, and the U-loop is the expansion band, which is required every 30 meters as per the law and as per engineering to absorb the expansion of the steel. Now what we are working on going ahead is the potential available in the country. So our initial idea, to be very honest, was to make steam, reduce air pollution, and make some money. now what we feel is that there can be much better things that can be done. And that is like, for example, in Delhi NCR, very recently, the Honorable NGT has issued an order that all the industries should shift to PNG, pipe natural gas. And we know it is a big challenge for the industries because they have to compete with countries like China, Sri Lanka, Thailand for their products. And if our country decides to shift to pipe natural gas, everyone is sure that they will not be able to compete with these countries. On the other hand, we know that there is a big time challenge in Delhi NCR again on the straw burning. Parali is the word they are using in the farms. The reason is that they are not getting any money. If the farmers spend 2,000, 2,500 rupees per acre, they can, if they are given 2,000, 2,500 rupees per acre, they will be happy to give this straw to a buyer, to any buyer. But currently, no one is paying that money. The boilers are not designed for these fuels, these feed. Therefore, this is burned in the farm. So we see a very big opportunity here. One, this can be taken for controlled burning, where the ambient air pollution will be reduced. One. Second, the coal will be replaced from the boilers, the industry, which is currently majorly importing from Indonesia and South Africa. And the energy can be received from the waste which is being burnt in the farms. So we have a very good win-win situation. One, we are reducing open burning. Second, we are reducing fossil fuel burning and instead using the biomass. Third, we are creating a circular economy where our farmers will get more income. Fourth, we will be reducing the forex outflow of our country. And fifth, the most important thing, our industries will be saved. So we have discussed with Haryana government, the Haryana government for Panipat region at least, they have already conducted a feasibility survey, which was done by SteamHouse again. And we are now expecting a tender from them, which will be on PPP basis, public partnership model, where the land will be provided by the HSIIDC, the Industrial Area Development Corporation of Haryana, and the project will be done by a private party like SteamHouse maybe. So, and we have seen these things happening. Industries are being penalized. Industries are being closed. In Haryana, we have seen that most of the times they close the industry for 15 to 20 days in the months of December and January because of pollution. One more case that is coming up is Vapi GIDC, for example. They have 34 paper mills now. And these paper mills have waste coming out, which is now undisposable. They are sending it to the cement factories 506 kilometers away from them and spending 2,500 rupees per ton. Not only spending 2,500 rupees, they are also adding to carbon footprint by transporting this fuel. What we have decided is we are setting up a project in Vapi itself, which the boiler will be running at 1100 degrees and the residence time for the flue gas will be 2 seconds to disintegrate dioxin and furan. And it will use only this waste. Now, again, if you see that the capacity of steam that can be generated in Vapi by using this steam is 60 tons per hour. The fuel that can be saved, coal that can be reduced, the import that can be reduced is around 1.29 lakh tons per year. And 100 crores of forex outflow can be reduced. And you would believe that the buyers for these, this steam is all European buyers, the industries that in Vapi, who are European industries who have their head offices in Europe, are very happy to buy this kind of steam because it's a green steam for them. Just one sec. So the third case study where we are working on raw municipal waste in Surat. Surat has around 5,000 tons of daily generation of municipal waste and 1.5 million tons of legacy waste, which is lying on the floors here. So the idea is that we will be setting up boilers which will use raw municipal waste. There will be no segregation required. And instead, around 5.5 million tons, 0.5 million tons of coal that is being imported in Sachin GIDC alone will be reduced, and a green steam will be available. Surat Municipal Corporation or the municipal corporation of the city will get rid of the headache of managing this waste. There is a cost added to management of this waste. 2, 0.5 million tons of coal import will be reduced. 3, fossil fuel burning will be reduced. So the total requirement of steam in Sachin GIDC is around 350 tons. Initial project that we are doing will be 120 tons per hour, 2 boilers of 120 tons per hour. That will consume 600 tons per day of raw municipal waste. And these projects are already operational in countries like Japan, China, European countries, UK, even Russia. So we are just bringing the same technology here. The capex here is going to be very expensive, very high. Each project is almost 4 times, 5 times more costlier than the current projects which we are doing. But the economics can be very interesting going forward. The temperatures here will be around 850 degrees and residence time of 2 seconds. And you can see this is a schematic diagram where a truck comes and dumps the whole municipal waste into the pit, and this can be then taken to the boiler. And there are gas conditioning tower, back filters, and fly ash silo, which will actually help in managing all dioxin furan, and a conditioning of dioxin furan traces which are remaining will also be done in the back filters. So these technologies are already proven everywhere. Around 1400 installations are already existing in these countries. One more case is the GIDC, again almost center of Gujarat. There is a company coming up which has which will be manufacturing carbon black, and the tail gas that will be generated, methane, would otherwise have to be flared in the sky, in the air, and instead we will be burning it in the HRUs, and there will be 100 tons per hour of steam generated from this. And this steam will be supplied to the industries in the area. So again, we can understand that 1.7 lakh tons of coal consumption will be replaced in this case. So the Dahej capex is only 2 crore rupees, while the capex for Surat project was around 200 crores in the initial stage. Panipat, as I have discussed, the demand there is 450 tons, and currently we'll be again doing 120 tons. And as we discussed, we are also going forward towards green energy. So green hydrogen is something which we have on our mind. And with the big companies in India promising that green hydrogen will be available at $1 per kg, it is very exciting. It can be even cheaper than coal in that case. Also, we are working with a Korean company where they have already started supplying torch of like plasma torches. These torches give a flame of 3000 degrees, and the electrons actually, atoms break into electrons, and the reaction is very fast. So the efficiency can further improve by 7 to 8% in this case. So these are the advantages when a bigger company or a professional company comes in, or even for that matter, if an association is doing this. I'm not saying that a private company should always be doing this, because the potential is very, very huge. There will be all kinds of people that have to get involved into this, and a lot of new technologies can be developed once the professionals are involved. So even the Surat Clean Air Policy, which has been a part of NCAP, has been considering common boilers. They have earmarked 225 crores for reducing industrial air pollution, and 102 crores for to stop the open burning of municipal waste. So we understand how serious the cities, the state governments are for managing this municipal waste. But this municipal waste, I will say, is an opportunity. The challenge for the city is an opportunity for companies like us. So yeah, that is all about the current projects and going forward.
Vishal, thank you so much for getting deeper into the conversation. I have a question, and maybe this would be useful for everybody over here. What are the industries or whoever gets this fitting done? What is exactly their role in the entire process, like from planning to implementation to execution? What all are they expected to, give in terms of time, effort, and even money?
If I'm understanding it right, you are asking the company which will be establishing common boiler, the role of these companies, right?
No, that is you, right?
Yeah.
I'm asking what is the role and responsibility of the MSME owners or the large companies who end up signing up for steam houses, community boiler?
Yeah. Now I got it. So one, there should be a cluster where at least, as I said, 15 to 20 tons per hour of steam consumption is there. So they should make a cluster or a group of the industries which can opt for it. Then a physical survey is to be required to be done on other challenges that can occur, like the electric cables, etc., going on the road. And I'm like, that's it. Their other role is to sign an agreement, pay a deposit. The capex is all done by, in our case, SteamHouse is doing all the capex up to their doors, and the metering system is to be paid by them, and the PRS has to be bought and installed by them. So that is very nominal. I think the whole expense on this side is around 3 to 5, 6 lakh rupees for an industry that is consuming 4 to 5 tons per hour, which is the most common case. And bigger industries who are consuming 25, 30 tons, they'll end up spending 15, 20 lakh rupees. So the cost on capex is very less. Deposits, yes, 1 month deposit, like any other utility supplier will prefer.
Okay, got it. I'm letting Mr. Ramesh, I'm allowing you to talk ek bari. Can you unmute yourself and ask your questions, Mr. Ramesh? Okay.
Good evening. Are you able to hear me, Vishal?
Yeah, I'm able to hear you, Mr. Ramesh.
Thanks for the lovely presentation. Basically, I'm an accredited energy auditor. Okay, so I do all these type of studies generally. One reason the question she asked me allowed me to ask this question is, most of these small scale industries they take the route of non-IBR boilers. And second thing, even though they have a IBR boiler, they keep the pressure reducing station near the generating end, thereby further loss of energy is done. And whenever we propose them to go for an IBR a high pressure line till the production block or at the user end, there is a resistance. So what has been your experience in this? Thank you.
Thank you. So talking about non-IBR boilers first, and I totally agree with you that there are many industries that are, I will say, compelled to use non-IBR boilers because of the economics. I will not ever say that the industries will fully do this. And with the experience with the boiler inspectors, we have seen that boiler inspectors are also very happy, so that they can now ask them to shift to common boilers instead of allowing them to use non-IBR boilers. At times they have to have blindfold because they also want the industries to keep running. So this is a good solution. I will again say that they shift to common boilers. So very recently, I'll take a minute extra. Very recently, in one of the events, someone from Andhra government said that there are 330 industries in one industrial area almost that are all into cashew nut processing, and all of them have 340 kgs fixed capacity of boiler. And we can understand that these boilers are challenging. They don't have any air pollution control equipment. Safety would have been surely compromised. So for such areas, for such people, it is a very good solution, I will say. One. Second, as you rightly said, that they really don't want to have the PRS shifted. So we personally don't get indulged into it. We, as we said, that we supply the steam at their doorstep and then let them decide. And very recently, we have also internally discussed that we will appoint an auditor to audit our customers and help them at cost of SteamHouse to help them improving their efficiency and save and reduce energy losses and enhance safety in their plants.
Yeah, thank you. I have other pointers. Nowadays, the industries, various industrial clusters or industrial estates are being established by various state governments. So where they initially lay, like one of the industrial estates I am working close in Karnataka, they have a common effluent treatment plant and power supply is also centralized. So why not at the start itself, you try to sell them the idea of what you said, centralized steam generation. It will help, no?
Yeah, it will surely help, and that is what we are doing now with the help of NGOs like ISC and all the people. We are trying to spread this word to the industrial estate developers as well, that please come up with the idea, incubate the idea in the project planning itself. And for example, PM Mitra policy, which has come up for the 7 mega parks, they have taken common boilers as a part of it. The Honorable Minister herself with whole of her team visited the common boiler here in Sachin and took a note of it. And they are also giving subsidies on these in these industrial areas for common boilers as well. There are many private park developers who are currently talking to us on having these concepts inbuilt in the idea. So we are already doing that, and we will again on this platform suggest that we should pass this word to every industrial estate developer that it should be a part of the concept itself.
Thank you. I'll try and do this. Thank you, Vishal, for the opportunity and the lovely presentation.
Thank you.
Thanks, Meghna, for unmuting me. And
Thank you. I'll take Mr. Sudhakaran's question. Which is cheaper, coal or gale gas?
Of course, coal is cheaper even on today's date, because gale gas, exactly, I'm not sure what are the numbers, but the private companies or the companies that are supplying CGDs here are supplying gas at around 76 rupees. So the steam cost will be in range of say around 7 to 8 rupees per kg, while we are currently selling at around 4 to 4.25 rupees. So you can understand that the cost is much cheaper on coal even today.
And how is wet bio sludge used? How can that be used? Wet bio sludge?
Wet bio sludge can be used. As I said, we are also working on the raw municipal waste. Both have almost same challenge, that the moisture content is very high. So the resultant will be a little lower pressure of steam. So 12 is again a lower pressure, I'll say. So we say high pressure when we need around 35 to 45 bar for generating power. So yes, wet biofuel can be used, but depending on the moisture content, there can be a requirement of additional liquid fuel or something, depending on the moisture content.
Okay. And how would this work out in high fluctuating loads, especially in the textile cluster? And even Gujarat has a lot of fluctuations. So what are the problems that you face? How do you manage them?
So I myself own 2 textile process houses in Sachin GIDC itself, Surat. And we ourselves don't consume steam for 3 hours in the evening and 3 hours in the morning. So net almost zero consumption is there in these hours. So it is not at all a problem. And as I said, the minimum turn down ratio for these boilers is around 20%. So if you have a mix of some other industries as well in the system, like there are some chemical consuming or these industries, that can be one way out. And we have been internally discussing again that when we commission our projects, which will be especially for textiles, the municipal waste projects that we will be commissioning for textiles, we will put some kind of benefit for these non-peak hours or off-peak hours, so that the price of steam, say for these off-peak hours, is 3.75 rupees or 25% saving. If the people say, people will themselves start making out a way. So we have to actually, work it out. It is not impossible, I'm sure.
I'll request Mr. Raj Kapoor to unmute himself and ask his questions.
Hello, Vishal ji. Very nice thing you're doing. So once I visited my family in Manchester, so there they have this heating steam system available. So are there any government or private companies which are doing in India? And second, are the banks financing this in India, and how much funds have you raised till now?
Yeah, so thank you, Raj Kapoorji, for your kind words. Number one. Number two, yes, they have city gas. District heating systems in Manchester and these countries. Yeah, and it is almost similar. In India, I believe we are the only company, and we brought this idea to the country. Though this concept is nothing new. It has been in the world since 1300s kind of years, and government is not into this business. Any other company is not into the business. And sorry, what was the last question? I really missed it.
So is this a new project? So
How
are you getting bank?
I agree. So in 2014-15, banks were not at all giving us the debt because they considered it to be a paper concept, which might absolutely fail. So we had to mortgage our properties for that. Now the bankers are very confident. This year we are targeting around 500 crores of Steam sale alone. And it's almost doubling every year. So the banks are very confident. We currently have around 150 crores of term debt, out of which 80 crores is yet to be used. We have around 45-50 odd crores of working capital from the bankers now. And good bankers like HDFC and Axis Bank have financed us, supported us. Also, we are intending to go public this year. This November, we should file our DRHP, Feb kind of, we should hit the market.
Perfect, thank you. We have no questions yet. I'll now take this a bit forward, and if we have more questions, we'll come back to a Q&A again. I would now like to invite Nasha to give us thoughts on how we could take this into a make it more scalable. We already have 3 pilots and many more pilots, and we've seen that most of them are coming in and around Gujarat and Maharashtra and Haryana. Nasha, can you throw some light on what should basically Vishal keep in mind when he's trying to explore beyond India, and what is the demand like in the regions that you are working in?
Yeah, definitely. So thank you, Vishal, for sharing with us exciting opportunities and already like proven case studies. So I think from my end, as Meka kindly introduced, so I work for ISC, but from the Mekong region, and we're working on similar topics related to sustainable manufacturing. Primarily, the program in Mekong focuses on the textile and food processing industries. And we work primarily with the brands, global brands, like the likes of the Nike, the Adidas, the Puma, the Levi's of the world. And we work with them and with their strategic factory suppliers. So we're all talking about garment factories as well as the fabric factories here. So within our context, primarily driven by the brands. I think it's similar to what we heard about in the comments and questions here. Majority of the global apparel brands are committed to the UNFCCC charter for fashion charter. So meaning that they are committed to the title of this event, Net Zero Pathway. And in doing so, Scope 3, which are their factories, also included in this pathway. So they are also pushing the same target to the certain level of targets, right down to the factories level. And what we have been receiving in terms of feedbacks, in terms of requests so far related to this topic is highly relevant, meaning that many brands have the coal phase out target, particularly focusing on the boiler technology, because the majority of the factories in Vietnam primarily, and to a minor extent in Thailand and Cambodia, the 3 countries that we're working in, they're using primarily well, a number of them use coal with a minor mixture of biomass at the moment. So, and also when we're talking about the fabric mill, for example, they use 6 boilers, for example, in one factory. So I think that already, and there is a big need to shift to more efficient, one is more efficient, energy efficient boiler system. And second one is more and more into the biomass. So shifting to non-fossil fuel option. I think therefore like the voices, the feedbacks here from the Indian context resonate fairly well with the Mekong region countries as well that ISC is also operating. And this idea and concept of the common boiler definitely resonate and relevant as well in the context of Mekong. So happy, actually, I would like to have a follow-up conversation with you and see if there's any replication that we could also see in terms of the Mekong region as well, learning from the exciting experience and also proven cases from India. Thank you, Meka.
Thank you. Vishal has a question for you, Nacha.
Yeah, Nachaji, thank you for kind words again, and we are excited to listen this from you. Very recently, I'll just like to share this. I was visiting Jakarta and West Java and Bandung region for some textile business just 3 months back. And the whole idea shifted from our textile business to common boilers, and the people there were very keen on having such projects there as well. So, and it can be very much replicated. So we'll really like to take your help and do a few more seminars, maybe with sector specific seminars, and maybe get some opportunity of business as well as helping the environment there as well. Thank you.
Thank you.
Vishal, before we close, there's one more question. Whether the focus force maneuver clause is applicable or not. Sorry, I don't understand this.
Sorry, let me check the question myself. Sorry, where's the question? I can see.
I am just unmuting Mr. Sudhakaran, and
Yeah,
then
that would be
maybe
better.
he will be able to take it. 1 minute. Can you unmute yourself?
Yes, Megha.
Okay.
Can you hear me?
Yes.
Yeah, we can.
Yeah, very good presentation, Vishal. And is that force majeure classes applicable for these projects?
If we talk about our recent experience, like COVID itself, when the force majeure kind of thing was applicable everywhere, but we were very fortunate that many of our consuming industries were pharmaceutical industry, so we did not have to actually shut down any day. And this generally helps the industries, like for example in Surat, in Diwali, the industries are mostly closed, but a few are still running and they want to run the show. So for them, the steam is still available. If I understand your question right, this was it.
Yeah, the one is complete shutdown, like COVID situation. I also asked for the COVID situation, how you managed. And secondly, we in Tirupur cluster, you see a lot of fluctuation is there in textile cluster. And then, and as you said, Diwali and Pongal holidays are there. How you manage those situations, and during this COVID situations, how you manage the fund management, and what is the end user? Will there be burden? Financial burden is pushed on towards them?
No, we don't pass on any such burden as such, because one, the major raw material is fuel itself. So if you're not consuming steam, there is no consumption of fuel. So there will be no cost pass on as such, one. Number two, for example, Tirupur, we should have, say, multiple boilers. Instead of having, if there is a demand of 150 tons, we should have 3 boilers of 60 tons. So when only a few industries want to actually run the show and 70% are not running the show, they can still get the steam. And in worst case, if no one wants to run the show, we take this opportunity of such vacations to get our boiler maintenance done, and the yearly passing process to be done. So we in Surat, we generally get it done in the Diwali times.
Okay. Already, I think CTPs can work on this, because CTP have members within them. So I think CTP also requires steam and power, and the steam can be used passed on to the members also. I think this
Yes,
can be out in
exactly.
how people in Tripur. We can make a meeting for that also.
Sure, sir. And believe me, this is a very feasible solution. People will never get burdened on like why did they get in two common boilers?
Yeah, definitely. And subsidy parts also we have to work out more on that.
Subsidy we don't believe in, because number one, they don't give subsidy. They just keep moving you around. That delays project. Number two. Number three, you never know, after a few years suddenly CIG will come down and say, okay, something is wrong and we all are in trouble. So let's not get into it. Let's do our business. We are Indian industry is capable of investing in its own business. They don't need money from anyone else.
But because since we have already have that experience for CTP, so I think ZD plan, so it'll be easier for us to move.
So let's do it. Let's do it. All the subsidy that will come, we will pass on that money to the industry itself.
Sure.
We will invest in the project.
Good. And existing boilers can also be taken into your consideration. That is, we have a BC.
No. This is a very good question, and for everyone, I'll want to answer this. We should have our boilers within our plants, always ready to run. We should understand that this is like electricity, a new utility coming in the market. So when we all have EB, the connections on the EB electricity boards, we always have our DG sets on standby.
Yeah.
So similarly, we should have our boilers on standby. At the end, this is a utility coming from outside. If you are okay that, okay, once in a while you don't have a supply, then it is good for you. You can get rid of your boilers. But if you're not okay, you want a constant supply, you want at least 99% plus uptime, I will say you should have your boilers on standby. And we will not take responsibility of running those boilers.
Okay, good.
Thank you, sir. Thank you so much.
Mika, you are on mute.
Sorry. Mr. Senthil, can you please unmute yourself and ask your question?
Yeah, yes. Hi, can you hear me?
Yes.
Yeah, hello, Mr. Vishal.
Yeah, I can hear
Thank
you.
you for the presentation. Just you highlighted the cost of the CFBC is high compared to the AFBC. So how about the efficiency of CFBC comparing to AFBC on the range of above 50 tons per hour capacity?
So when we say AFBC boilers are 83% efficient, CFBC claims that they are 85% efficient. So it's only 2% of
Okay.
efficiency. So the payback is not that great, I will say.
But what about this operational point of view? It have some numerous issues, or because most of the plants are upgrading to the CFBC, so due to their operational issues and kind of an ash generation as well. So we need your views on this.
So with the ash, what we are currently doing is we are making fly ash bricks within our plant, or we have engaged a few micro entrepreneurs and finance them to make bricks from our fly ash. So
Okay.
yes, ash generation comparatively is, I mean, like I'll say 10% higher than the CFBC boilers, not more than that, I would say. One. And
Okay.
and yes, there are limitations of capex. Therefore, we prefer AFBC boilers. Also, finding land in such industrial clusters is also a very big challenge. So we have to compromise on the design for sure.
Okay. And you highlighted the footprint size also big
Yes,
on the
that's what I've said.
CFBC.
Buying a bigger land is always going to be a bigger challenge. Buying or
Yeah.
renting a land.
Okay, fine. Yeah, it's clear. Thank you for your answer.
Thank you so much.
Thank you, Mega. Yeah.
Thank you. Two follow-up questions from my side. For all the participants, actually, we are planning a site visit to most probably Sachin's site, right, Vishal? And we would prefer to do this post monsoon because it's pouring in Gujarat right now. I will send everybody a mail asking for their preferential date. and then we could plan a site visit. In the meanwhile, if you do have any questions or any follow-up thoughts, you can email to me or Zahid. The presentation also would be uploaded and the YouTube video would be uploaded. Sorry, this video would be uploaded on YouTube and I will share the recording with you in the same mail where I'm sharing the doodle form for the site visit. Does anybody have any parting thoughts, feelers? We have one more question. Has SteamHouse received any funding till now? Maybe we have investors in this call too, Vishal.
Oh, thank you so much, sir. Please share my number with him, especially. So yeah, we have funds from bankers, lenders, as I said. We are, as I said, we are in the process of IPO, so we are also working with a few companies on pre-IPO money, and so yeah, we are looking for investors. Anyone is welcome.
Perfect. So maybe we'll put you in touch if there's anyone coming across from an investment point of view.
Please, ma'am. Thank you.
But this was a good session. Does anybody else have any questions left that we should take in? Because we do have 10 more minutes. I think we're okay. We'll be happy to take questions, queries, and hope to meet you all for this site visit in Gujarat. I'll now close the session and thank you all. Thank you, Dr. Basak, for joining in. Thank you, Nasha, for giving us your point of view and encouraging this and taking this forward in South Asia. Thank you so much, Vishal, for taking out the time and patiently answering all the questions. And hope that this good work is actually, we help you scale this up further. And thank you, Zahid, for arranging this session for us and taking all the pain of meeting with all of us. Thank you, everybody.
Thank you so much.
Thank you, everyone.